Alright, so in this video, we're going to be doing some practice with the scalar triple product. Okay, we're going to be finding the scalar triple product and we're going to be applying it to a couple different problems. The first of which is we're going to try to find if the vectors 1, 5, negative 2, 3, negative 1, 0, and 5, 9, negative 4 are coplanar. Okay, and we know, like we said in the last video, that these vectors are going to be coplanar if your scalar triple product is going to equal 0. Okay, so what we're going to do is find the scalar triple product. Okay, we're going to do A dot B cross C. Okay, and first we'll need to do B cross C. Okay, so let's start with that. We'll do B cross C. Okay, and that's going to be 3, negative 1, 0 cross 5, 9, negative 4. Okay, let's find the cross product. So we gotta do our 3 by 3 matrix. In our second line, we're gonna have 3, negative 1, 0, and then our third line we have 5, 9, negative 4. Okay, let's find the determinant here. Let's start off with our I hat component. That's going to be a negative 1 times negative 4 is 4, minus 9 times 0 is, well, that's just going to be 0. So we can just say 4. Okay, and next we have minus j hat. We have times, this will be a 3 times negative 4 is negative 12. And we get a 0 when we do 5 times 0. Next we have plus k hat. And we'll have k hat times, we have a 3 times 9 is 27. And then we're going to have minus, I drew a plus there because we have a 5 times negative 1, which is negative 5. That makes this thing plus, and we have plus 5. Okay, so altogether, we get 4 I hat plus 12 j hat plus 32 k hat. Okay, and that right there is your B cross C. Okay, and you can also write that as 4, 12, 32. Okay, now that is what we're going to plug in for our B cross C when we do our dot product. Okay, so we have A dot, well actually I'll write out what A is this time. A is 1, 5, negative 2, and we're going to be dotting that with the vector that we just found, 4, 12, 32. Okay, so when we end up doing this dot product, we have 1 times 4 is 4, plus 5 times 12 is going to be 60, and negative 2 times 32 is going to be negative 64, and you can see that when you add all those up, you get 0. Okay, and well, if your scalar triple product is 0, that means that the vectors, these vectors are going to be coplanar. Alright, so for our next problem, we want to find the volume of the parallelepiped created by the vectors. We have vector A, which is 1, 3, 2, vector B is 3, negative 1, 6, and we have vector C that's 5, 2, 0. Okay, so the volume of a parallelepiped is the scalar triple product. Okay, that is the scalar triple product, and so we'll be doing again A dot B cross C. Okay, that's the first thing that we'll be doing. Now, first we need to find B cross C. We'll do that over here. Okay, let's set up our 3 by 3 matrix. We have our unit vectors I hat, j hat, k hat on the top. We will have our vector B right here, 3, negative 1, and 6. And then we'll have vector C below it, 5, 2, and 0. Let's find our cross product. We're going to first have I hat, and that's going to be times, we have a negative 1 times 0, that's 0. And then we're going to have, it'll be minus 2 times 6, which is 12. Okay, next we have minus j hat. Okay, always remember there's a minus there. And we'll have 3 times 0 is 0, and then we'll have a negative 5 times 6 is 30. And then finally we have a plus k hat, and that will be, we'll be having a 3 times 2 is 6, and then we'll have minus a 5 times negative 1 is negative 5, so this is going to become plus 5. All right. Now, this will be equal to a negative 12i. This will be plus 30j, j hat, and then this will be plus 11k hat. Okay? So there you go. That is your vector. Okay? That is negative 12, 30, and 11. Okay? So we need to now dot this with your a vector. Okay? So let's do that here. We have a 1, 3, 2 dot negative 12, 30, 11. Okay, and that'll be on that half of the board. Okay, so we have a 1 times negative 12, that is negative 12. We're going to add 3 times 30, that is going to be 90. And then we're going to add 2 times 11, that's 22. Now, 22 minus 12 is going to be 10. 10 plus 90 is 100. So, right there, our volume equals 100. So before I end this video, I wanted to mention something that I actually said in the last video, and that was that I mainly dealt with just problems seeing if a set of vectors were coplanar and not if, for the finding the volume of a parallelepiped, okay? And I think I had 1 or maybe even 2 questions on that, 1 on a quiz, 1 on a test, but I never had any on finding the volume of a parallelepiped, okay? So, what I would say is that I think that the coplanar problems, that's a little more important. I mean, literally, it's just if the scalar triple product is 0, okay, as long as you know how to find the scalar triple product, and you know that if it's 0, your vectors are coplanar, that's really it. But that just has more applications, and I think that's why you'll see problems like that, rather than trying to find the volume of this random 3D object. Okay, so anyways, that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space, the explanation video for the scalar triple product, and the next video in the series. Lastly, if these videos are really helping you, consider supporting me on my Patreon, which I have linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.